Yeah, hi. Good morning and good evening, guys, and welcome to the first week session of Apache Solr. And this is what we are trying to cover in today's agenda. And we will be going through an overview about enterprise search and some basic concepts about the search, like inverter index, forward index, why we need a search or why we need a search engine, and how the enterprise search is working, and what are the different processes involved in an enterprise search, and about the search relevancy and faceted search, and then we will just go over the syllabus, like Apache Solr syllabus. And as Siri mentioned, to give you a brief introduction about myself, like I'm Sony Thomas. I'm based out in Litmus 7 Kochi office. I started my search working with ATG search back in 2010, and later I worked in a couple of Apache Solr projects back in 2012. That was in an old version of Apache Solr in 3.5 version. And then along with Walmart, I moved to Endeca Search, and ATG acquired Endeca at that time in around 2013 time, and we moved to Endeca Search in 2014. I started using Solr 7 in last year only. Like before that, I was fully into Endeca Search. So if I just give you a brief overview of my search expertise, starts with ATG search, then Endeca search and Solr search, and having some Elastic experience, but not much. Today's session actually, or the entire session of Solr, how we are planning is like a lot of guys or a lot of who opted for the Solr might not have idea about what is Solr, or even like what is the enterprise search. So what we think about a couple of sessions is like give you a brief idea about what is a search engine, or like how the search engines will be working in an enterprise world, or like in an e-commerce world, like what is the need for a search engine. That is what we are trying to cover today. And next week, actually, we will be trying to cover Lucene. Like Lucene is the base of Solr, base of both Solr and Elasticsearch. Like if I just say it in a correct way, like, and those are the two most popular search engines available right now in the market, even for the e-commerce sites, Elasticsearch and Solr. Next week we will be covering Lucene, and after that only we will be starting exploring more about Solr. This week we will cover the basics of search. Next week more about Lucene, and after that we will be starting the Solr. We will be
Join the meeting.
I will be covering through the course curriculum, like the week-wise, what all we will be covering, and we will try to cover the reference also today, if time permits. Without going into much more, actually, we will start with enterprise search. Search is some feature actually we all are using in our day-to-day activity. Like at least once in a day, we will be using Google search to find something, or to search for some place, or like find the weather condition, or by using some voice assisted search navigations, or like using Amazon Alexa or Siri or Google Home, or some applications we might be using that end up in searching for something. But what we are going to study is about Solr, right? So Solr is an enterprise search application. So the question is like, what is an enterprise search, and how it difference, like what's the difference between an enterprise search and the commonly used Google search or some other search functionality? To answer that, actually, this is the wiki definition for enterprise search. Except practice, enterprise search is a, one second, let me And the pointer, yes. Okay. Enterprise search is a practice of generating content and make it searchable to a defined audience. Like in case of enterprise search, it will be it is just giving the search functionality to a defined set of audience out of multiple enterprise type data sources like database or CMS. The input system to an enterprise search can be different type of data sources can be an input system to an enterprise search, but the searching users will be a defined audience. And another definition is something like it is used to describe the software of search information within an enterprise, though the search function and its results may still be public. In a way, like we can just compare it with the enterprise search of e-commerce application. Like if you go and search in Amazon or like in Flipkart or some sites, right? The users of that particular or the audience, we know like who will be using this particular search. Users will be searching for what kind of data they might be looking for, and those information we know, like that is something is given, that's something actually is specified by the defined audience, and the data set also, like it's also definite, like the e-commerce data or the product information or like any other interesting information, those are the ones that is getting searched, and that's about the enterprise search. And these are different searches available, right? Like there is web search is there that we all know, and desktop search or mobile app search is there, like in case the search is happening over the content inside on a computer, single computer, or on a content from a single mobile app. This is another terminology that I just want to introduce to you, like SEO. Like when you start learning search engine or search applications, and if you just try for help or go and check for some documentation on search engines, this is another terminology, or you might get navigated to multiple sites that is specifying about search engine optimization. And what is search engine optimization means? Like it is a process of, as per the definition, it is a process of increasing the quality and quantity of website traffic by increasing the visibility of a website or a web page to users of the web search engine. Like when we Google for something, right? Like when we search for something, how the ranking happens in an open search engine like Google, and that's about SEO. Or if we are hosting a website, how to make sure like our site is coming on top of search results, Google or Bing or like some other search engines, some open web search engines. Search results is all about SEO. And SEO and this enterprise search are two different worlds. So I just want to make sure like you just heard about this. At least you just heard about this. You should aware like this is another terminology that is used in our system, and it's different from what we are going to discuss. So what we are going to learn as part of our Solr. These are some list of enterprise search engines available right now in the market. Some are not available in the market, and for example, say like that Google SA search appliance. Like we just said, like Google is not an enterprise search engine, but Google had a search application, Google SA, and that is not available now in the market. And instead of that, there is a Google Cloud Search is available, and Apache Solr is there, and customized Solrs are also there. Like this is an open source version of Apache Solr, and Lucid Works, for example, is a customization written, or the enterprise version of Apache Solr, where they have given some customization on top of Apache Solr, and Elasticsearch is there, Oracle Endeca is there. And on the right-hand side, I have just listed some new guys. Like here, the Vespa is there, SIFtype is there, Algolia, Bloomberries, Twigle is there. Like these are the booming ones right now in the market. Like more of a big data ones, or more of a machine language specific ones, or natural language processing engines that are available in the market right now. To learn about the search engines, right, we just need to understand two main concepts, that is inverted index and the forward index. If you have a document and if you just want to find the data that is inside the documents, you can either go for looking into the forward index, or you can look for the inverted index. Forward index is the mapping of document into the words, like each of those documents and the words inside the document. Suppose like this doc1 contains 3 words, and again doc2 contains another 3 words, and doc3 contains another 2 words. This is how the forward index will looks like. An inverted index is like the index that is available on the backside of any book, that about a particular exam, like against the words, actually it is just giving a details of documents, similar to those index available in the books, like mapping the word to the document, or directs you from a word to document. That's about the inverted index. And the same example here actually just given in the way of an inverted index here. Like you can see the sky comes in doc1 and doc3. So from the word sky, it's very easy for you to navigate to the documents, like which all documents are below, there actually the sky, the word sky belongs to. Like from a particular word, it's easy for you to navigate to the documents using the inverted index. That's a basic concept. To discuss more about this fundamental search problem, I would like to introduce you to an example. This is an example listed in a book, a very good book, like Solr in Action. And we already purchased this particular book for you guys, and we will be providing the soft copy of that book, the PDF version of that book to you to learn Solr. And this particular example will give you an idea about why we need a search engine for the search applications, or why we need a search engine to find the data sets. This example again is talking about searching for some data set inside the books. Suppose you have these kind of books are there, and the name of the books are given like this, and you're just going to search for a book named Buying a Home. I'm just discussing about these things on the left hand side. Like you are just going to search for the term buying a book, and these are the books those are relevant to the term buying a book. The Beginner's Guide to Buying a Book, How to Buy a First House, Purchasing a Home, Becoming a New Home Owner, Buying a New Home, Decorating Your Home. These are the book titles, those are relevant to the search term buying a home, and these are the ones those are not relevant to the search term. Fun Guide to Cooking, How to Raise a Child, Buying a New Car. These are some books that are not relevant to our query. And if you just want to implement this search functionality, like when you search for something, or search for this particular buying a book, buying a home search term, and you just want to list all the books having the title, how we can implement this particular scenario. Whether it's possible to implement this using a relational database or any database, like that is something actually we are just trying to analyze over here. And what about if we just searching for the entire search term, like this is the search term, buying a home. If you just try to search for the entire search term using the equal operation, there won't be any match, since exactly there is nothing matches here which just says like buying a home. And what about we go for a like operation in a relational database? Like the like operation with the percentages actually will do the matching for the words that contain these words, right? Like and what about we go for an AND operation? Means a combination of and like is used to retrieve the books having the name buying a home. Means a book that has the text buying, a book that has the text a book that has the text home, but that can be in any combination. There is no need it to be in that just in terms. That way can we try to retrieve that particular data. That's what we are trying with the second query over here. And as you can see on the right hand side, this is what will happen if we just use a relational database with such a query. The matching books will be buying a new home. Like this is a matching one, but these are the valid non-matching ones, like beginner's guide to buying a home, how to buy the first house. Like nothing matched over here in this particular query. Purchasing a home, like these books are not matched with our query even if we go for a like. What about we try for an OR operation instead of AND? When we try the OR operations, interestingly, actually, there are more matching happens here. But again, like the one that we just discussed over here, how to buy your first house, that is not matched for this query also. Even if we go for an OR operation, or even if we go for a like operation with some percentages to pull maximum possible data sets. That's what we are trying to do over here. But even with that, when we use this over a relational database, right, we won't be able to find some results that should retrieve as part of this query. And at the same time, see, like the first one, a fun guide to cooking. This should not be retrieved for the search for buying a home, but here, since we go for the OR operation and an OR with a, just retrieve this particular document also. See, like then this one, like how to raise a child. Right, there is a match happened to the A over here, and another match happened over the raised over there. As you can see, like what is happening with the relational database is like a complete wrong set of data is getting retrieved over the documents when we are going to find the data sets, right, out of using some relational database. And these are some points, or like something actually that we can infer from this particular example. It is very difficult, or it's unable to distinguish between the words. Even if we go for the like operation, it's unable to distinguish between the words. And this relational databases does not understand the linguistic variations, like buying versus buy. It's not possible for a relational database, or like it's very difficult for a relational database to give all these linguistic variations in a query. And it don't understand that synonyms, like purchasing. See, like here we have a book with title Purchasing a Home, and it's not possible. It came over here since much happened with or condition, and it's a wrong query altogether anyway. And the point is, with the relational database, it's not possible to fetch the documents having the synonyms. And as we can see, like some unimportant words like a just considered over these scenarios, and that results in wrong results retrieved from the available set of documents. And another important aspect is about the relevancy ordering. And coming slide also actually we will just discuss about relevancy. And this is one important feature if we just if we just understand any search engines. And when you search for an item, the order in which actually the results appear for that particular search term is matters to the end users or the end customers. So in a relational database, it's not possible for us to define the relevancy. Like we can do some order by or some other options in the query, but those order by or like those ordering won't give you the needed relevancy of the documents. And as you can see, like the queries become slow. Like when you go for the like operation or some additional ways to retrieve more documents matching to the search terms, it becomes more slow, those queries, and these are some of the drawbacks of using a relational database or some other data structure like that to find or search for the documents. So the question is like, how search engines solve this problem? As we just discussed before these slides, using that inverted index concept, that's how actually search engines solve this problem. On the same example or on that example of the documents, this is how an inverted index, like it specifies about the Lucine's inverted index. Lucene is the search engine that is there running behind Solr or Elasticsearch. And this is how actually an inverted index will index the data, or inverted index will read the data in case of a search engine. Whatever document are there, and against those words, actually it will index index the document number. This is just an example. Like that's why actually it is given that document number. As you can see, like in this scenario, if you're just going for buying a home, buying against the term buying, you can identify the documents 4, 5, 6. Against the term home, you can identify the documents 2, 5, 7, 8. And to discuss about A, actually, A in case of a search terminology, A is will be termed as a stop word. Like those words that we should not consider for our search. Even if you go and search in Google using these words like a, the, and like all these will be ignored by the search engines in normal scenarios, and until and unless you go for some phrase search. Phrase search is you are just asking the search engine, I just want the results for the search term in exactly in this order that I am giving, like in some option, like you just giving some double quotes. Inside that, actually, you will be giving the search query. And those double quotes will identify that search query as a phrase search, and search engine will look for the exact phrase. And if you are not going for such options, in normal scenarios, these words, so these terms will be treated as stop words by search engines. And the other thing that we discussed about the synonyms, right? Like synonyms is another term actually we just discussed in this example, right? Like we are just searching for buying, but we know like buying and purchasing are two similar words, and that is a synonym for a search engine, and even if we are not specifying purchasing engine has the intelligence to identify this purchasing is a synonym. And also like home or house, like if you are searching for home, house is a synonym, and the engine should match for the results for those documents that is containing house, or those documents that is containing purchasing, and that is about the synonym mapping. About the synonym mapping and about the linguistic variations, those things, relevancy ordering, those things actually we will discuss further in the coming slides. Actually, we'll discuss few things. And after that, in the coming sessions also, actually, we will cover more about these terminologies. But altogether, what I just want to discuss with you guys is like why a normal relational database or any other data structure is not sufficient for a search operation, and what is an inverted index, like how the inverted index play a vital role in search engine, and it is the heart of any search engine's work. To give you some more points about inverted index, as you can see, all the terms in the index is mapping to one or more documents. Like here, as you can see, the home is mapped to multiple documents, new is mapped to multiple documents. So that from the term, actually, it is very easy to identify the set of all the documents. It's not pointing to a single document, it will be pointing to all the documents that is matching to this particular term. Terms in the inverted index are sorted in ascending lexicographical order, like again, like that is giving an option for a binary tree traversal, easy for a search engine to easily navigate, easily identify a particular term that you will be looking, and to identify the corresponding documents. And that's why actually it is sorted in the correct order. And one more thing actually would like to point is like the terms are transformed to lowercase text. Something again, like when we come to these examples listed over here in relational database scenarios, like if the input information, like in this scenario, the input is the name of the books, that might be a combination of uppercase and lowercase letters with multiple special characters in between. Like there could be in different scenarios with the text ordering and the text appearance in the input data set. And when the search engine creates the inverted index, right, like it will just it's not only doing this particular lowercase, it is doing multiple type of text analysis and text conversions. To give you an overview of like those analysis, I just want to point it out these things. Like as you can see over here, it is just converting these into lowercase letter. So it's easy for you to identify the results without concerned about the uppercase, lowercase scenarios. Yeah, this is what I told you. Like additional to this lowercase, many more additional text transformations. Modification means the existing text can be modified, or some new data can be added, or something can be removed during the content analysis. Like that content analysis process is known as the indexing. That's what actually we are coming to on the next slide. And during those content analysis process, the text transformation will happen. Whatever there in the input text, right, that will be transformed to a format for the search engine to identify easily the results. And that text transformation, in those text transformations, the data can be modified, it can be added, or it can be removed. Anything can happen during the processing. We can define that, like based on our business scenarios, based on our our domain. We can just define like what we need to do on each of those input data sets. And this particular process, right, the content analysis process is known as indexing. And that's about, that's something actually I just want to discuss with you next. How an enterprise search engine works. As you can see in this particular process flow diagram, like this is a small representation of all those complicated steps that are happening inside the search engine, like a reduced representation of those steps. These are on an eagle view level, actually on a high level view. These are the main steps that is happening in any of the search engine or any of the enterprise search engine. As you can see, like there are two processes happening over here. And the top one, sorry, like the first one on the top is known as the indexing process. And the second one on the bottom is known as the search process. First, we can just look into the bottom one. That is something actually we know, like we are much aware of, or like what we used to do in at least in an e-commerce site. Or from our browser, actually, we are just searching for some search text. And the request will be reaching in a web server, you know, like any server like Apache, Tomcat, or like any JBoss or any server, actually just reaching there. And there might be some query processing, like whatever you have provided as part of your search query. There could be some query processing that is happening, and the results are retrieved from a search engine, right? That's what we are discussing now about the search engines, right? So the search query that you have given is hit into a search engine, and search engine is providing you the results. From where the engine will provide you the results? That's the question. And the engine will be providing you the results from an index. And that is again another common terminology that is used to identify the data set where the search engine will be looking to find the results. Index. It is something like the inverted index that we discussed over here. Like this, we said this is the Lucian's inverted index, right? Something similar to this, where engine can look the data sets to easily identify the results, right? That's about the inverted index concept. And for the time being, actually, we can just say like this is the indexed data in the search engine. So search in like indexed data in the sense like it might be stored in some file system format that is readable only to the search engine. Means the search engine will be looking for the data only inside the index or only inside those particular file system format which engine is aware of to identify the results. That means like it won't be firing any query to any other relational database or any other source of documents to identify the results when you search for something. Means the search operations is involving only these over here, like only till the index, the search operations. When you fire the request, it is coming through the web server. It is processing. Some processing will be done by the query processor, will be reaching to the engine, and engine will be fetching the results from the index. It won't be coming here. Like so, the index is the source of truth for the search engine, and index is so the question is like how the index is getting generated, and that is the process is known as the indexing process, and that's what is given on the top side. And these are the source of truth for the indexing process, or like these are the it can be a specific data set fetched from the web not the entire website. That's not we are discussing from an enterprise search point of view. Might be some specific website data set specific for the domain or specific for the users. It can be a specific database, can be a relational or a NoSQL DB, can be a set of documents, a set of emails. Any source of data can happen in case of a search engine. So those database or documents or the data from the web, we need some web crawler to crawl the data from the web. The documents or the database need some corresponding accesses to access the data over there, and there will be some processes involved, like a document processor, which is doing some transformation that we discussed in the previous slide, like whatever the source data, right, that will be transformed to some other format that is defined over here in the document processor, and there will be an indexer. This indexer is responsible for doing the indexing operation. And at the end of the indexing operation, it will generate the index files. And that is about the indexing. So indexer input the index data files, and the querying will happen on top of this index. As I told you, right, this is just a pictorial representation of too many complicated processes that is involving during the search operation and the indexing operation. And when we walking through the Solr indexing or like Solr search operations, we will just go over like what are happening in an actual scenario of a search and indexing operation. And actually, in the real world scenario of an e-commerce site like Amazon or Walmart or like Flipkart, it won't be a single search engine, like it won't be a single web server. Multiple search engines will be there. And indexing can also happen using multiple indexes. Like in case of Solr, each engine can take care of the indexing operation also. So it won't be a single engine or it won't be a single index. The index will be shared across multiple boxes or multiple engines, and it can go replicated over the replication. And that's about replication and sharding, and those features we will discuss further in the coming sessions. Like my point is like this is a high level overview of what is happening inside a basic search and indexing operation. In real world, actually, there will be more scenarios involved with the search and indexing operations. And
yeah. Quick question, Sony.
Yes.
To go back to the diagram. So this index, right, does it have both indexed data as well as the original content of the data? Because so I'm trying to picturize when the result come back, it will come the actual expected document or the result, right? So the index have both index data as well as document, or only have the index data?
Just going back to this particular example, right? The question that we want to answer there is like what the end customer will be looking for, and what you just want to retrieve as part of your search results. So you just need to define the response, and you just need to define in what set of fields you just need to search for. Again, in case of an e-commerce site, right, we know like we all are working in retail domain, and we know like when you search for some data over an e-commerce site, the search should look over the products to identify the products, right? On those scenarios, actually, we will define over these fields. I just want to run my search. In this example that I have given, the search is happening over only the title, like the document title. But in a real world, or in case of an e-commerce site, it can be a brand, it can be a category, or it can be a name of the product. So in which all fields the search should happen, that we need to define. That is something that we are defining for the search operation. Then the second thing is like what all we need to retrieve, like in the search results page, what all information you just want to display to the end customer, right? Those are the data that you should index, like the data that should be searched for. All the data that you will be searching might not be part of the results page. Few data sets, for example, there will be a meta search might be there, meta search keywords might be there, that won't be there in the response. Or you will be looking to find the valid products based on a product start date and end date fields. You might be looking for the product for a particular store. You might be looking for a future products based on some coming soon start date and date field. Like those are some fields that is used for the search operations. And some of the other set of fields is the one that you just going to display over the site. So from the input documents, you should index those data sets that is required for your search operations, and those documents that is needed for your display operation, right? Whatever needed to retrieve by or returned by the search engines, and only those data set you just need to index. The rest of the data you don't need to index. So out of all the available data available for the product in case of an e-commerce site, right? You just need to index only those data set that is needed in the search results page, plus those data that's where actually you're just searching for. Did I answer your query? Or
yeah, so like so those data will be indexed, as you said. If you go back to the diagram, right? So the index, yeah, I understand what are the columns or fields you wanted to index. You are indexing and you are storing in the index database, right? Whatever the final thing, right? But if what happens if a client browser want other than index field, so does it able to return the information, or it does not? Means my question is, the index database, whatever shown in the picture, does it have only the indexed data, or does it have both indexed data as well as the non-indexed data for the retrieval process?
Index data, I think you are just confused with the term index data. Index data doesn't mean like this is the data that you are searching for. Like the search operation is looking into a defined set of fields inside the indexed data. So indexed data means that includes the data that you looking for the search operations plus those fields retrieved in the search response. So it's a combination of searching field and the additional fields that is needed on the search response.
Okay, but, I got it. Okay.
Yeah, but at the same time, actually, you can define that, and I will give you an example. Like if time is there, let me check.
Yeah, maybe like going forward.
Yeah, we can cover these things in future. I think that's better. Like you can define your business need, and you can just define different design approaches over there. In the search response from the engine, right? You can just retrieve only the document ID. That is another approach. You don't need to retrieve the entire set of document information from the search engine. Once you identify these are the documents, document is a terminology that we will be using going forward for all your information. Like document is the format in which a search engine is indexing the data. At the end, actually, document, it will be in some document format in case of Solr or in some other search engines. So once the indexing is over, the search engines will be storing different documents, and the search engine can store only those fields for the search operations, and it can provide you the document IDs. But this web server or the query processor, right, there you have another module to retrieve the document based on the document ID. That is another design approach that you can have, but that document retrieval, then it becomes more time consuming when we discuss about the performance point of view of a search operations, right? that is not the ideal case. Like ideally, actually, if engine can provide you the response that is needed for the web browser, that will be the ideal case for a search to respond quickly to your search query. Those things that is something actually we can further discuss later. I think I have a few more slides left. We can just quickly cover those things also before we wind up for today's session. This is another point I just want to cover as part of introduction, like the search relevancy. And the relevancy ranking is the process, this something that we already discussed, right? When we search for some search term, what we need on top of the results, the first few documents should be the most relevant one. That's what we will be trying to achieve, right? These are some data points actually given, like on Google, 94% of people never go to the second page of search results. 70% of shoppers never look at second page of Amazon results. Like those guys, 70% will be looking only the first page. In Amazon's first 3 listing on any search account for 65% of the clicks, and 35% of people click on the first item. Like out of the 3, actually 35% will be looking for the first item itself. That just indicates like how important the relevancy is in a search world. We should make sure like all the valid products are there in the first page itself, and the first few, like ideally the first row should contain the most relevant one to the end users. To the end user in the sense like those for your search term, if you just go back to our scenario over here, right? Like there will be multiple books matching to this particular search query over here, and out of these matching documents or matching books, which is the most relevant one? That is the relevancy question, and that is something actually we will discuss more further in the coming sessions. But 2 terminologies I just want to cover as part of this one is precision and recall. Precision is about the percentage of documents in the results that are relevant. Like out of all those documents that you retrieved, right? How much are the relevant ones from those results that you have? For example, you just search for something and you got around 1,000 products or 1,000 documents in the response. How many on those 1,000 are valid ones? That is about the precision. And the second terminology is recall. Recall is like in the index, like we just discussed about the index, right? The index is the set of all the documents. In the index, how many left? That is about the recall. Means out of all those documents in the index, did the engine fetch all the valid ones? Or in the same example that we said, right? We just got 1,000 items, whether only the 1,000 items are there in the engine or more than 1,000, like say like another 500 was valid there and we just left, engine is unable to identify those another 500, like that is about the recall. And these are 2 precision and recall are 2 important concepts that just evaluate the engine's relevancy, how relevant a particular document or how relevant your search response, that is identified by the precision and recall. And this is again another pictorial representation of this relevancy and precision and recall. See, like when you search for a set of documents, these 4 scenarios can happen. There could be a true positive scenario. True positive means a document is returned and it matches to your query, like that is a true positive scenario. And a false positive can happen. A document is returned but is not a correct match. These 2 scenarios are indicating your precision code. Like precision is about how much percentage of documents are returned are relevant, right? Like a document returned is relevant, a document returned is not a correct match. That is about this true positive and false positive. Like true positive is here and false positive is here. Those two are indicating your precision. Then there is a true negative, like document is not matching and it is not returned. Like these are your return set in this diagram, and this joining is the one that is indicating the true positives, and the true negatives is the other set of documents that is there in the index file. And but those are not returned, and that's correct only. Like those true negative are the document that is not matching to your query, and they are not returned by the engine. And this is the correct scenario, true negative. And another scenario is false negative. Like a document is not returned, but that matches. This is about a complicated scenario, or like it's a most frustrating scenario that is very difficult to debug also. Like if the document is there in the results and it is not matching, it's easy for us to identify. And also the scenario like a document is not returned, that is also something more easy for us to identify and debug. But the scenario like a document is not returned, but that matches, that is it is something difficult. Like, and these precision and recall are two terminologies that is used to indicate the relevancy of the search results. And before we wind, actually one more concept I just want to give you is about the faceted search. And faceted searching is again, like this is some feature actually we will be using in our searches. Facets or dimensions or the filtering criteria will be listed there for the ease of navigation purpose or ease of narrowing down the results. And faceted search is a technique which allows the users to narrow down the search results by applying multiple filters based on set classification. Yeah. That's what it is a definition for faceted search. And facets are the pre-configured or the configured set of fields inside the search operation that is helping the end customer who knows what they want to narrow. Like there will be two different, on a broad level actually there will be two different set of users. One is set of users actually who just searching for some random search name. They don't know like based on what condition actually they just want to retrieve the data. Another set of users are the one who knows what I am looking for, like this is the specific brand I am looking for, this is a specific size I am looking for, this is a specific store I am looking for, or this is the, in case of a GM site, this particular model is the one that I am looking for, or like this is the resolution of, in this scenario, this is the resolution of camera I am looking for. And those users are the one who knows exactly what they are looking for. And for those users, if you provide the filtering options, right, it will be easy for the user to find out the results, even if we don't provide the exact set of results, right? We might be giving a large number of results to the end users, and out of those large set of results, actually, we should provide some option for the end users to filter out the data that they are looking for, and that is the faceted search. And that is what about the facets, like these are known as facets, and the facets are having a name. Like in this example, the manufacturer is the name of the facets, and these one like the Canon, Sony, Nikon, and those are the facet values or dimension values known in the search terminology. And the faceted search is another important concept in search and search operations that will allow you to search for or to that will allows the end users to navigate, filter out the irrelevant results and to identify exactly the results that they are looking for. And would like to share with you that syllabus also. Yeah, this is the book that we discussed in between, like Solr in Action. And Sini will share you that PDF copy to you guys so that you can just go through this PDF version of this book. To give you an idea about like the topics that we will be covering in different set of sessions over the weeks, right? Today actually what we are trying to cover is, I think this you might got some idea about like how the search engines work and those concept about the inverted index, forward index, and what is the need for a search engine, and basic concept like the relevancy and the faceted search and those things. Like we try to give you a video tutorial in Pluralsight and in Coursera or some Udemy, and we tried over there, but all those topics or all those videos are just basic ones. Like they're not covering much advanced version of Solr that we just want to learn. That is the reason why we cannot provide you any of those courses. Like that is not worthwhile. But instead of that, we just given possible set of links to different tutorials other than this Solr in Action book. Solr in Action book is very much if you just cover those books, that is sufficient for you to learn about Solr. But other than that, few concepts that you just need to understand other than the Solr in Action books is given in the reference. And in some scenarios, actually, we have listed some YouTube also, like YouTube videos also for your learning purpose. And this week, as we just said, like we're just trying to cover the basic concept about the search engines. Next week, we will be covering about Lucene. Like Lucene is the base of Solr and Elasticsearch. That is the engine that is giving you the results. But that is another standalone installation. We can install it standalone also, and that is sufficient for us to do some search operations on top of some text or on top of some documents. And that Lucene search is something actually we'll be discussing in next week, and we will be having some. We'll try to have some hands-on on later. Actually, you can also try some hands-on in this Lucene to search for some. For example, you can just index the documents in your laptop, and you can just do some search operations to select you inside the PDF documents. And there is something actually, for example, Windows is also not providing you, right? You cannot search for something inside a PDF, right? But using Lucene, if you have Lucene in your laptop, and if you index the PDF documents inside Lucene, it's possible for you to search for the content inside your PDF documents. Those kind of things we will look into next week. After that, we will, and after the week only, we will just start with Apache Solr, and we will go over the installation and system requirements and the basic directory structure in that week. And then we will be covering the Solr admin UI. Then later we'll be going into much depth of Solr, like schema information and the indexing and Solr configs. Then about the Solr search relevancy and other search operations and the advanced concept. Some advanced, not the very advanced concept. It is comparing with the other ones. This is the advanced search concept, and we will be covering the Solr Cloud also. And that is, I think that is something possible for us to cover within 10-12 weeks, and there will be some assignments after that. And if we just discuss about Solr, actually there will be additional topics to cover other than these things with Solr, but based on your interest and like based on how we will cover these topics, actually we can decide whether it's possible or whether it's needed for us to cover anything more on top of these. I think that's what I just want to cover in today's session.
Yeah, Sony, in that series, right? Series of links, right? So, what are the important ones that people have to look into? Like there are many links, reference links. Whether we have to go via the Solr's action. Hello.
Yeah, in Solr action, actually, whatever need to cover exactly, I just given that Sini, like this is that one corresponding Solr in action book sections I have given, like 1.1, 3.1, 3.2, 3.3. Those are the sections. Like out of these links also, right? You don't need to read through the entire set of. Just pick up like whatever you need, like. See, out of those ones that we discussed initially, I just try to avoid as much as possible. But I thought like these might be useful for the guys to go through, like, or for the future reference also they can just refer to these things.
Okay.
You should go through the Solr in Action book. That is a must. Like, though that's a very good book, and the concepts are well written over there. And some concept like the relevancy part in the book might not easy for you to understand right now, and no need to like go in depth of those concepts. For example, so like again, like I like we are not going in the order in which actually it's given in the book. For example, in the book, in the first chapter, it is given like an introduction to Solr, and those Solr concept is the one that is given in the book. But what we are trying to cover in our session is like only the first 1.1 is the session, like why you need a searching. That's the only thing that we covered today, and you don't need to go into this 1.2, 1.3. Those things will be going in the next coming week. And then what I want you guys to go through is like about this one, like about this search, matching, and finding 3.1 section. That's what I have given here. That's where the different concepts of a document and the search problem that we have given, and the inverted index concept, and that matching, like how the matching can be done. And those, for example, in case the Venn diagram and the Boolean matching, and those things are given over here, and that will be easy for you to understand. But the difficult part might be something like more complex relevance calculation logic. For example, the vector representation of a relevancy calculation is given, and equation is given with the concept of time frequency, inverse document frequency, and coordination factor, and boost factor, and field normalization. Those things will be difficult for you to understand now. Those concepts no need to cover, but just go over here the basic concept of this, how the frequency will affect you, the search results, and those things are the ones that you can cover now. Any questions? I'm happy to answer.
Only whatever part you have explained was clear actually. So I think once they all go through that Solr in action as well, so we'll be in a good position. So that if they have any queries, they can reach out to you, or they can ask in the next session also. That is also fine. Okay. Anybody has any questions?
No, Sini. Sini, the PPT also you'll be sharing?
We can share, say, no
Yeah.
problem. We'll be sharing that.
Okay, thank you.
Okay. Thank you, Sony. Thank you, everyone.
Thank you.
Thank you, Sony.